This is basically a character editor that I wrote, an animation editor rather, that I wrote years ago. It has the capability of saving keyframes. If I use this frame manager down here, I could save like a default skeleton position. Or alternatively, you can do like inverse kinematic based movement based on a certain joint hitting a target location. So I'm just going to go ahead and show you repositioning with the inverse kinematics. I'm not going to get into like all the frame saving and stuff. Honestly, all of these menus are super finicky and the tool isn't super stable. But the inverse kinematic stuff is pretty stable, and once it's played back, all of the animations play correctly. So I'm just going to go ahead and showcase the inverse kinematic solver. Basically, I can select a bone. I can do so by pressing the directional keys and sort of navigating his skeleton hierarchy. You can see the yellow box indicating my current selection. So if I want to, I can make him actually wave. You'll notice I've got depth of 3. That means that it'll include this bone and 2 more in terms of trying to rotate the angle to like hit the objective. So I'm going to go ahead and activate that by pressing space, and then here we go. You can see I can actually make him wave. So I'm going to go ahead and just turn that off for a second, and then turn off frames, and I'll make him wave. So you can actually see the character's joints move quite naturally for like a ragdoll. Typical ragdoll animation, you can sort of like see a very obvious scene, but I'd like to think that this is actually like pretty well done. You can see like he has a wrist, and I mean it's obviously 2D graphics. It's not like solid 3D mesh or anything that you can transform properly. But I did create a 2D mesh that does something similar. It's much simpler though than like a weighted animation like deformity mesh at a joint or something. Anyway, I'm gonna go ahead and turn back on the boxes so I can see where I am navigating to. Gonna go back and let's go ahead and play with his tail a bit. Let's tug on this character's tail. So I'm gonna go all the way down to the end here, and we'll showcase like a few different levels of. So you can see I can just move his tail tip if I've got three spaces. But let's say I've got like 10. I'm not sure how many segments there are in his tail, but there we go. So you can see I can actually start to make his tail move like in a kind of wiggly way. Now, if I wanted to get really finicky, I could actually go in, and I believe there's a weight that I can set on each one of these, but it's somewhere in this movement dialog here. And it has been quite a while since I've done this, so I'm just gonna go with the default weight, 1 for everything. And just one moment here. And yeah, basically I'm going to go ahead and increase this. Let's bump this up a bit more. Let's say 20. Okay, so if I do 20, you can see that suddenly his tail is very snaky. It's trying to reach my cursor. That's like its objective in a relatively naturalistic way. If I point all the way over to some place where it doesn't get, it does continually try to make it there. It looks like it's straining, kind of. And this is just the nature of the solver that I use. If there's a nice solution for it, it'll just stay in place. And you'll notice that it will snap around a little bit, but it actually is pretty good about not snapping in a completely awkward way. For the most part, it can solve in the, like, basically when you've got an inverse kinematic solution, there's multiple ways that you can get to like that point if you've got enough joints. There might be like just tons of possible solutions. This tail might loop around, or it might loop around the opposite way, for example. But you'll notice that for the most part, it's pretty good about not like swapping around. Like I can sort of like click and I can drag it around like this, and then it tries to stay like this as best it can while still hitting the objective. And likewise, if I rotate it around like this, you'll notice it is actually rolling and unrolling the correct way. So it's not just completely random. And I can't remember the name of the algorithm that I used to do this, but in any case, yeah, that's my inverse kinematic solver. And let's just end with a friendly wave goodbye. Just a second here. Let's move his other arm this time though. Set this to 3. I could make it so that, a second. There we go. So yeah, we've got, you'll notice that he's got like a little bit of interesting arm movement here. This is going based off of the maximum angles that are allowed, max and min. And you can see it's pretty good. Pretty good. I could put him in a fighting pose. Let's just leave him like that. So yeah, that's it, and thanks for watching.